Hello, and welcome to this NCI CRDC Tech Talk on DCF indexing processes. I am Faye Booker, a Senior Scientific Support Analyst and a member of the DCF User Services team. In this Tech Talk, I will provide an overview of the Gen 3 platform as it relates to CRDC and a comprehensive review of our indexing operations. This will include pre-indexing requirements, minimal elements of a manifest, DCF manifest validation, indexing verification, and other resources for your review. As background, the Gen 3 platform consists of open source, interoperable software services that support the emergence of healthy data ecosystems. Gen 3 aims to accelerate and democratize the process of scientific discovery by making it easy to manage, analyze, harmonize, and share large and complex datasets in the cloud. Gen 3 is fair, making data findable, accessible, interoperable, and reusable. Within CRDC, the DCF framework services enable platforms to receive, manage, and share structured and unstructured data in a secure and scalable way. We supply user authentication and authorization to data, and data object indexing service, which mints permanent digital IDs called global unique IDs or GUIDs for global objects. This service tracks the storage location and hash of every file in the Data Commons object store. As an overview, the Gen 3 indexing service is a hash-based data indexing and tracking service providing 128-bit globally unique identifiers. These GUIDs are designed to be accessed via a REST-like API or via a client, and it serves as an abstraction over the physical data locations, providing a GUID per datum. These identifiers will always be resolvable within the Gen 3 indexing service and will always provide the locations of the physical data, even if the data are moved or reside in multiple locations. The number of objects indexed by DCF have grown tremendously in the past 2 years. In early 2022, our index objects numbered just under 3 million, and that grew to 42 million by the start of the current fiscal year. That growth was mostly from GDC, and bringing the Imaging Data Commons online with their first major data releases. This fiscal year, 2023, also has seen tremendous growth from nearly 42 million records to 54.5 million. This has been a result of continued growth by the Imaging Data Commons, as well as bringing the cancer data services on board. As in all years, there have also been major releases from the GDC, the PDC, and the ICDC. Another measure of utilization are the number of indexing jobs or manifests by each of our data nodes. The 55 manifests received by the end of April represent a 37.5% increase over the previous year. Slightly over half of our work has come from CDS, although the Proteomic Data Commons have also been active with monthly releases, redactions, and modifications. While there are fewer manifests from IDC and GDC, it should be noted that these are very large manifests and often takes weeks and sometimes months to process. Now, on to what indexing actually does. As an overview, prior to indexing a job, the data owner or node has several responsibilities. First, you need to provide read access to GCP or AWS buckets via a bucket policy and notify DCF of what the name of your bucket is and where it is located. The data owner will then create an indexing manifest and upload that manifest to a shared file location. The data owner then notifies DCF that a new indexing manifest exists, and DCF will validate the manifest and notify the data owner if there are issues that need to be resolved. We'll also supply an estimated date of completion, usually within 2 to 4 days of the manifest receipt for smaller data nodes. DCF will provide the original manifest, any modifications made to that manifest, and processing log in a shared folder location. If the data node did not supply GUIDs, DCF will generate them and share a file containing that information as well. The DCF standard operating procedures are available online on our website at https dcf.gen3.org/standard-operating-procedures. The Indexing and Data Release SOP is a living document. It is also pinned in the NCI CRDC data release channel for your interest. Prior to indexing, each data node must notify DCF of any new buckets or projects so that fence and arborist can be updated. For buckets, we need to know the cloud storage provider. Is it GCP or AWS? And we need a specific bucket location, for example, US East. For projects, we need to be made aware of the dbGaP accession number or study title. This is so we can verify that we are receiving feeds from dbGaP once those studies are released. DCF requires a tab-separated values file with the following fields. Size, which is the file size of each file in bytes. MD5, which is the MD5 sum hash. ACL, a list of projects for which access must be controlled, or just an asterisk if access is to be open across all users. AuthZ, which is currently optional, the projects that a file is associated with. For example, /programs/project_name. URLs, the full path to the file. This field can contain multiple locations, as will be described elsewhere. And optionally, a GUID. It's important to know that if you supply your own GUIDs, you must use the CRDC prefix, which is DG. For uppercase D, upper letter F, uppercase C/. You can see examples of manifest records in our SOP. DCF maintains a shared Google Drive where partners can upload their manifests. Access to this drive is controlled, and access should be requested through our Leidos tech lead. The URL to the drive is bookmarked on the CRDC data release Slack channel as well. Manifests are uploaded to the relevant staging or production folder. And finally, once you've uploaded something, you should notify DCF by posting in the CRDC data release Slack channel, emailing us, or if we have a different workflow, utilizing that method for notification. If you do post in the Slack channel, please tag the relevant DCF staff in your post for your highest visibility. The DCF Google Drive has folders for staging, which is used only by new nodes that are coming online, or for nodes who are adding new features, particularly for our cloud resource partners. Otherwise, the folders are broken down by data node. So there are folders for the PDC, for IDC, ICDC, and CDS. Soon we will also have folders for the immuno-oncology data commons and the clinical trial data commons. Within each of these production folders, there are a series of subfolders. The archive folder contains indexed manifests from prior fiscal years, and then the next folders are 0-new, which is where new manifests get uploaded. After this, the following three folders are used by DCF to indicate where the process is. The one pending folder is where manifests are moved if there are found to be problems with the manifest, as we discuss in our validation procedures. Otherwise, it moves to the processing folder. And then once it is done, it gets moved to a subfolder within completed with the files that I mentioned previously. So once DCF has been notified that a manifest is available for us to index, we perform manifest level checks. The first is the most obvious. Is the manifest in a TSV format? If yes, it is, we move to the next check. If it isn't, we'll try to reformat it to TSV. We'll also notify you that you submitted the manifest in the wrong format, but we will proceed. We then ask, are the required fields present, and are the column headers correct? If yes, we'll proceed to column value checks. If required fields are missing, so for example, if there isn't a file size field, we'll move the manifest to 1 pending and notify the submitter. If the required fields are present, but the column headers are not correct, For example, you inserted MD5 sum instead of MD5. We'll change the field name and we'll notify the submitter that we've done so and proceed. We next ask, are there any missing values, blanks or zeros in any of our required columns? If there are not, we'll proceed to values validation. If there are, we'll move the manifest to the pending folder and notify the submitter that we've run into issues. We then move to validation of individual columns. So if provided, does the GUID include the CRDC prefix, i.e. DG.4, capital D, capital F, capital C /? If it does, we'll proceed to size validation. If not, we'll prepend the prefix or correct misspellings. So for example, if you specify DG.4DCF, and we'll notify you once we've done that and proceed to size validation. If provided, are the GUIDs unique? If they are, we proceed to size validation. If they are not, we move the manifest to pending and notify the submitter. Next, we validate the size field. Are values stored as positive integers? If yes, we proceed to ACL validation. If not, we'll proceed to the next size assessment. Are size values stored as real numbers? And can that number be reformatted as an integer without data loss? So for example, it's not uncommon for spreadsheets to store numeric fields with a decimal and 2 digits of precision, but those decimals are often .00. So that's a case where we could convert it to an integer without data loss. Similarly, with really large sizes, it's not uncommon for Excel or Google Sheets to convert a number to scientific notation. In that case, we will just convert it to an integer, forced integer, and proceed. However, if there's any other case, we'll move the manifest to the pending folder and notify the submitter of our findings. Next, we will validate the ACL field. This field is used to indicate whether a collection is controlled or open. If controlled, the format of the field should be a list with the PHS number enclosed in single quotes. So for example, square bracket, single quote, PHS, and then the number, the 6-digit number of that PHS ID, a single quote, and a square bracket. If this format is correct, we'll proceed to auth-z. If it isn't, DCF will correct the format and inform the submitter. If the data are open access, we also validate the field format. It should be square bracket, single quote, asterisk, single quote, square bracket. If this is the correct format, we'll proceed to auth-z validation. If, however, you specified an older format, such as single quote, open, DCF will correct the field once and notify you, and then we will proceed to auth-z validation. Auth-z is a fine-grained authorization format for controlled and open collections. If the data are controlled or restricted by dbGaP, the format of the field should be square bracket, single quote, /programs, /PHS, and then the ID number of that collection. Single quote, close the square bracket. If this is correct, we'll proceed to the URL validation. If it is not, we will correct the formatting and inform the submitter. If the data are not controlled but open, we also check the format of that field. In this case, it should be square bracket, single quote, a / open in lowercase, single quote, closed square bracket. If this is true, then we'll proceed to URL validation. But if you have the format as simply an asterisk, DCF will correct this field and notify you. It's important to note that auth-z is not currently required, but it will become so when DCF implements RAS Phase 3. We next move to DCF validation for the URL. Does the URL begin with GS or S3? If yes, we proceed to the next step. If it isn't, this means it's not supported cloud storage. We'll move the manifest to pending and notify the submitter. We next check whether there are invalid characters in the URL string. We have a complete list in our SOP for invalid characters. If we don't find any, we proceed to indexing. If we do find invalid characters and they are spaces, DCF will contact the submitter, but we can also do a escape 20 substitution for spaces to get the indexing completed quickly. If we find other invalid characters in the URL string, we'll move the manifest to pending and notify the submitter. As a quick note, if DCF makes any changes to your manifest, we will create a new manifest with the DCF prefix prepended to your manifest name so that you know what you originally submitted and what DCF actually processed. Indexing simply appends records to the IndexD databases. If you did not provide GUIDs, a GUID is created for each record. And after indexing, DCF samples 5% of open access records and attempts to download. Note that if your data are controlled and DCF does not have dbGaP access, we are unable to perform this step. If we are successful, we proceed to final notification, and if not, we recheck our logs for other indexing issues. For your interest, the IndexD endpoint for any GUID that DCF has indexed is https://NCI-CRDC.datacommons.io/index/GUID. Gen 3 uses GA4GH data repository standards. The DCF GUID is the GA4GH DIRS ID. DCF operates a DIRS server, and files using DIRS IDs can be downloaded from a different endpoint on the NCI CRDC datacommons.io site. For more information about our GA4GH operations, I refer you to this URL on the IndexD GitHub repository. After indexing, DCF will create a folder in the 3-completed folder. Folder names are typically the dbGaP accession number plus a date of completion. For example, PHS 002790_2023-0307. The contents of that folder will include the original manifest, the DCF processing log, a DCF-generated verification manifest as an output from indexing, which does include the GUID if you did not supply one with your original manifest. And if DCF had to make any changes to your manifest as part of our validation procedures, the DCF modified manifest. Lastly, DCF will report completion of our indexing in the Slack data release channel, via email, or via any other workflow that the two teams have mutually agreed upon. It should be noted that the procedures outlined above apply to submitted manifest less than 100,000 records. GDC in particular is covered by a different SOP, which is available on the Gen 3 website. Other checks or operations can be requested by the submitter. So for example, if you are generating your own GUIDs, you may want to know whether they are in use already. Upon request, DCF can remove entire manifests or specific GUIDs from our index. If PII was accidentally exposed, DCF will remove impacted records from IndexD, as well as redact and republish any manifest and processing logs on Google Drive. It's also important that DCF also accept manifest to update or add to existing URLs. So for example, if you move your data from Google Storage to Amazon S3 storage, we could update the URL field. Similarly, if you wanted to have a replicated copy of your data on both Google Storage and AWS S3 storage, we can update the URLs to reflect that as well. If you have any questions that were not addressed in this presentation, please contact us. You can find us on the NCI CRDC Slack space, particularly in the data release channel, on our website at https://dcf.gen3.org, or via email at gen3-dcf@lists.uchicago.edu. Thank you very much for listening to this Tech Talk on DCF indexing processes.